Hey guys, welcome to week 6 instructional video. Today we're going over conjugate pairs. Last week we talked about acids and bases, the characteristics of both. A lemon is sour, and that's an acid. A base could be a cleaning product, and that would have a slippery feel, that would be a base. And neutral would be 8, which is water. Or I know a lot of the different materials said 7 or 8, so just know 7, 8, that would be neutral, such as water. Then we talked about the difference between an Arrhenius acid and an Arrhenius base, and that definition specifically deals with reactions that are in aqueous solutions, or also known as reactions that have water. An acid produces H+, which we know is hydronium, and a base produces OH, which we know as hydroxide. I think there was a little bit of confusion with these definitions, although a lot of your responses were great. Let's just make sure we know Arrhenius deals with water specifically, and Bronsted-Lowry came in and said that was too specific. Let's create a definition that covers everything, water, no water, whatever. But I still do want you to know that an acid and a base, even in the Arrhenius definition, it still means that a hydrogen's getting donated and received. It's just if when that happens and hydronium is created, that's an Arrhenius acid. If that happens and an OH is created, that's an Arrhenius base. But we're still talking proton donation and acceptance, okay? So let's go over Bronsted-Lowry real quick again. In a Bronsted-Lowry acid, a proton is donated, or a hydrogen. If you see, let's just say you have HCl on the reactant side, and on the product side you have Cl, that means that that hydrogen was donated. That would be the acid, okay? For a base, the base accepts the proton or the hydrogen that was donated by the acid. So if you have H2O on the reactant side, that would turn into H3O on the product side, and you would know that H2O was the base. Okay, so let's just practice a little. I want you to practice identifying the acid and the base in a reaction. So you're going to take the reactant side and you're going to compare it with the products to identify which one's the acid and which one's the base. So I'm going to hold up the equation, and I just want you to pause here and try to identify the acid and the base. Okay, you could pause it, so I don't really know why I waited. But anyways, so in that equation, HF would be the acid, because if you compare this HF to F, you know that that lost a hydrogen, donated proton. You're looking at H2O here. You see that there's an extra hydrogen over here. It accepted that hydrogen, so H2O in this equation would be the base. Water is actually the most common base and the most common acid. H2O can easily become H3O, and that would be it as a base, but H2O can also easily become OH and lose that hydrogen, and that would be the acid in that equation. All right, so let's actually flip that reaction into the reverse reaction, and then we're going to start seeing what I'm talking about when I say conjugate pairs. So let's take that very same reaction. As we know, the reaction was moving this way. We can actually reverse that reaction and make this the product and this the reactant. This the reactant and this the product. So let's look at that. So here on the reactant side, you have F plus H3O. So when you go to compare that F to HF, again, I'm not going to get too much into naming. I'm just going to say what we see. So when you compare those, you see that F actually gained a hydrogen on the product side. So that would mean in this case, F was the base. H3O, however, actually lost a hydrogen and is now H2O. So you would know this was the acid in this equation. So H and HF here would be what we call a conjugate pair, okay? H3O and H2O would be the other conjugate pair. Conjugate pairs always differ by one proton in their formula. And by one proton, we mean one hydrogen. So if you're looking for a conjugate pair, you would start on the reactant side. It works best that way. I just always move left to right. So starting from the left on the reactant side, F, find on the product side what differs by only one hydrogen. And in that case, it would be HF. So F and HF would be a conjugate pair, an acid and a conjugate base. H3O would be the base, so H2O would be its conjugate acid. And again, they just differ by one hydrogen, because as you reverse the reaction, and make it go the other way, what was the acid becomes the base, and what was the base becomes the acid. So I hope that'll make more sense as we practice. Let's do an example. So we know that they differ by 1. So if you have the reactant side but not the product, you could actually guess its conjugate pair. So if you know that HCl is an acid, then you know that its conjugate base would be Cl. If you know that H2O is a base, you know that its conjugate acid would be H3O, because all you have to do for an acid that donates a proton is take a hydrogen away. For a base which accepts protons, you would just add a hydrogen to the formula, and there you would have it. All right, so let's go through this. I'm gonna want you to pause in a second and try it by yourself, but let's just go through the first one. I gave you a list of acids, okay? What I want you to do is come up with the conjugate base. So for HCO3, the conjugate base would be CO3. Okay? All you do is take away 1 hydrogen. So go ahead and pause this and see if you can run through this list and pull out all of the conjugate bases. Okay. So let's go through them. So in this case, you have H2PO4. So the conjugate base would just be HPO4. Here you have SO4, HSO4, so the conjugate base would just take this hydrogen away and you would have SO4, which is sulfate, by the way. This is sulfuric acid. Anytime you have one of these polyatomic ions with a hydrogen on the front, it just turns that polyatomic ion into the acid of itself. So, anyways, here you have NH4. Over here, you would have NH3. You just take 1 hydrogen away. Here you have HCH3O2. HCH3O2. And that would just turn into CH3O2. All you do is take this hydrogen away and just a little bit of naming, that's acetate. Okay? So that's how you would identify conjugate bases from a list of acids. Now, let's do it the opposite way. What I've given you here is a list of bases, and I want you to identify the conjugate acids, okay? So as a conjugate pair, what would the acid be? So you have OH here as a base. The acid would just be H2O. So go ahead and pause it here and see if you can identify the rest of the acids. Okay, so for H2O, you would have H3O. For HCO3, you would have H2CO3. For SO4, you would have HSO4. And for ClO4, you would have HClO4. So you would just add a hydrogen to those. I don't know why I didn't put a line, so I'm sorry. All right, and that would be how you find the acid to the base. So now you know how to create or identify conjugate pairs. So now I want to take all of the skills that we've learned and try to put them together. And I want you guys to practice it all. So let's see here. Let me find my page. Oh, here it is. So what I'm going to do is I'm going to show you guys a list of formulas, and I'm going to want you to practice, but I'll do the first one with you. So I'm going to give you the formula, and you're going to identify the acid and the base on the left, and then you're going to identify what its conjugate pair is. So let's just look at the first one. And I know it's a little hard to read. So you've got H2SO4 plus H2O, and then on the product side, you have HSO4 plus H3O. So what we got to do here is find the conjugate pair to this. H2SO4, we've got HSO4 here. That would be its conjugate pair. So hydrogen, there was 2, now there's 1, so you know that's the acid. H2O, there was 2, now there's 3, so you know that's the base. If you're down a hydrogen, that's an acid. If you're up a hydrogen, that's a base. Okay, so here's that list for you guys. I tried to write them as clearly as I could. Just do your best though. So go ahead and pause here and see what you come up with, and then we'll go over it. Okay, so here you've got HCl plus OH, and then on the product side you have Cl plus H2O. So go ahead and start on the left side of the reactants. You see how you're down a hydrogen, so you've got the acid and the conjugate base. Up a hydrogen, so you've got the base and the conjugate acid. So that would be the conjugate pair, conjugate pair. All right, HCl plus NH3 turns into Cl plus NH4. So you find the conjugate pair, so you know that this is the acid and this is the base because you're down a hydrogen and you're up a hydrogen. So, last one. Sorry, that was my computer. You've got NH3 and NH4 as a conjugate pair. You notice that you're down a hydrogen, so you know that that's the acid. You're up a... No, I'm sorry. You notice that you're up a hydrogen here. So NH3, you're up one hydrogen, so you know that that's the base. H2O is down a hydrogen, so you know that that was the acid. Sorry for the mix-up there. All right, guys. So if you need to see that differently, I did create a PowerPoint with all of these notes and practice on there as well. Same practice problems, but just in a different format. So that might help you. For the assignments this week, all you have to do is watch this video and do the Google Forms. That's what I got for you, okay? I love you guys. I hope that you have a great Easter. If you need me, I'm here. Message me. Nora said she loves you too. Goodbye.